Hello everyone, I welcome you all to Startup Academy, your online gateway to ISS exam. This coaching is basically focusing on particularly ISS exam only, and we are focusing on 2026. So we have been covering the topic econometrics, which comes under statistics paper 3, which is of descriptive type and is considered as one of the most important and a little bit difficult topic. So till now, in the previous lectures, we have done SLR, MLR, and problems relating to these models such as heteroscedasticity, autocovariance, multicollinearity, and three problems we have discussed till now. And today, moving on further, we will discuss the fourth problem, which is endogeneity. That is, it does not gives us the right estimator, and there is something or some defect present in the model. Now uh, we have now the fourth is endogeneity. What is endogeneity? Now, one of the let us consider a model. Yi is equals to beta naught plus beta 1 xi plus epsilon I for all I goes from 1 to n. Now here, if our explanatory variable, which is x, or independent variable also we can call it, and our error term are correlated, then we say that this is the problem of endogeneity. That is, covariance between xi and epsilon I is not equal to 0. Then we say that problem of endogeneity exists. Okay, so we know that the formula for covariance is covariance of x comma epsilon is nothing but estimation of x epsilon minus estimation of x into estimation of epsilon. And we know that by Gauss Markov assumption that estimation of epsilon is nothing but equal to 0. So from here, this term will be equal to 0. And now we are left with estimation of x epsilon, which is not equal to 0. And hence we can say that our model is having problem and we need to work on this. Now we will discuss this problem both in simple linear regression model and multiple linear regression model. So firstly, for simple linear regression model, we are discussing simple linear regression model, which is also known as SLR model. So in simple linear regression model, the model is given by yi is equals to beta naught plus beta 1 xi plus epsilon I for all I goes from 1 to. Now in this, firstly we have been given that covariance between xi and epsilon I is not equals to 0. Estimation of epsilon I is equals to 0, and variance of epsilon I is equals to a constant, or we can say sigma square. These are the given conditions in the model. Now, by OLS techniques, estimation method, by OLS method, we will find our estimates, that is beta cap naught, which comes out to be y bar minus beta 1 cap x bar, and beta 1 cap, which comes out to be summation I goes from 1 to n ki yi. These two, estimation and OLS method, we have repeated n number of times, and I want you, if you have doubt in this, then you can watch the simple linear regression model, which is our lecture 1, where how we have calculated this. And if you know that, let's continue. So now we have to check whether these are unbiased estimators of our model or not, of beta. So firstly, unbiasedness of, we will check estimation of beta 1 cap. Now estimation of beta 1 cap is nothing but estimation of summation I goes from 1 to n ki yi. This is our estimation. Now we can write it as summation I goes from 1 to n ki estimation of yi. Now what is yi? Beta naught plus beta 1 xi plus epsilon I. So replacing that by your ki estimation of beta naught plus beta 1 xi plus epsilon I. Now all of this beta naught, beta 1 and xi are considered as constant, so they come out of the estimation and we are only left with estimation of epsilon I. And again, by Gauss-Markov assumption, estimation of epsilon I is nothing but 0. So our model is summation I goes from 1 to k, ki beta naught plus beta 1 xi. In here, we will not consider the Gauss. Here is a violation of another Gauss-Markov theorem assumption, which is estimation of epsilon I is not equals to 0. So here we are left with plus estimation of epsilon I. Now we will multiply with this. We will get summation I goes from 1 to n. This is n. Ki beta naught plus beta 1 summation I goes from 1 to n ki xi plus summation I goes from 1 to n ki estimation of epsilon I. This will become 0, this will become beta 1, and this will be summation I goes from 1 to n ki estimation of epsilon I. So we can say that estimation of beta 1 cap is nothing but beta 1 plus summation I goes from 1 to n ki estimation of epsilon I, which is not equal to beta 1, and hence this is not an unbiased estimator of beta 1. So how can we write this? We can write bias of beta 1 cap is given by estimation of beta 1 cap minus beta 1 is equals to summation I goes from 1 to n ki estimation of epsilon I. This can be written. Now again checking the unbiasedness of the second estimator, which is beta naught. So estimation of beta naught cap is given by estimation of y bar minus beta 1 cap x bar. So we can write it as estimation of y bar minus x bar estimation of beta 1 cap. Now y bar can be written as 1 by n summation I goes from 1 to n yi. This can be written. So we are left with 1 upon n comes out of the estimation, and we are left with summation I goes from 1 to n yi minus x bar. Now estimation of beta 1 cap is nothing but beta 1 plus summation I goes from 1 to n ki estimation of epsilon I. From here we have taken this. Now solving this further, 1 upon n estimation of summation I goes from 1 to n beta naught plus beta 1 xi minus x bar beta 1 plus x bar summation I goes from 1 to n ki epsilon I estimation of epsilon I. So by multiplying with this we will get beta naught plus beta 1 x bar minus x bar beta 1 plus x bar minus x bar summation I goes from 1 to n ki estimation of epsilon I. So our estimation of beta naught cap becomes beta naught plus x bar, sorry, minus x bar summation I goes from 1 to n ki estimation of epsilon I. Again, it is not equal to beta naught, and hence it is also not an unbiased estimator but a biased estimator. So we can write it as bias of beta naught cap is given by estimation of beta naught cap minus beta naught is equals to minus x bar summation I goes from 1 to n ki estimation of epsilon I. So by these two techniques we have found out that we get both biased estimator when there is endogeneity present in our model. Now if we discuss about multiple linear regression model. Now in multiple linear regression model, our model is given as y is equals to x beta plus epsilon. Now here we will consider that covariance between x and epsilon is not equals to 0. Here this is also violated. So now this is our model and all the information we have about a model. Now by OLS estimation method, we will get beta cap as x dash x inverse x dash y. This will be the estimator of beta cap. Now if we find the unbiasedness of this, if we have to find the unbiasedness, then we will find the estimation of beta naught, beta cap. So estimation of beta cap is nothing but estimation of x dash x inverse x dash y, which can be written as all these x are independent or constant, so they come out of the estimation x dash estimation of y. Now y can be written as x beta plus epsilon. So it will be x dash x inverse x dash estimation of x beta plus epsilon. Now opening the bracket, we will get x dash x inverse x dash estimation of x beta plus x dash x inverse x dash estimation of epsilon. On solving further, x dash x inverse x dash estimation of x beta is constant, so it will come out of the bracket. It will be x beta only plus x dash x inverse x dash estimation of epsilon. Here these two terms get cancelled and we are left with estimation of beta cap is equals to beta plus x dash x inverse x dash estimation of epsilon. Now again, which is not equal to beta. So it is also a biased estimator of beta cap. So we can say that bias of beta cap is given by estimation of beta cap minus beta is equal to x dash x inverse x dash estimation of epsilon. So all of this tells us that under endogeneity, we get biased estimator of our model. So endogeneity affects unbiasedness of an estimator. Now how will be able to resolve this problem? So there is a very famous very famous technique by using which we can solve this problem, and this technique is known as two stage or we can say 2 SLS method. 2 SLS method it is known as. So here we have to put the value in this method. We will first take the model, and then in first stage we will take an instrumental variable, and in the second stage we will put the instrumental variable in the model and find our values. So what happens is, if our model is given as yi is equals to beta naught plus beta 1 xi plus epsilon I for all I goes from 1 to n, and we know that covariance between epsilon xi and epsilon I is not equals to 0. So in stage 1, what we will do, we will take an instrumental variable zi such that covariance between zi and epsilon I is equals to 0, and covariance between Zi and ui is also equals to 0. So we will take both the error terms, and the covariance between the error terms and this instrumental variable should be equal to 0 to remove the problem of endogeneity. So let us consider xi is equals to alpha naught plus alpha 1 zi plus ui for all I goes from 1 to small n. This will be our this will be our xi. Now by OLS method, by OLS estimation method, we will get xi cap as alpha naught plus alpha 1 zi cap. We will get the predicted values of xi. Now in stage 2, we will substitute the value of xi cap in the model. We will substitute the value of our model is given by yi is equals to beta naught plus beta 1 xi plus epsilon I for all I goes from 1 to n. Here we will substitute the value of xi. Firstly, we will apply by OLS method. By OLS estimation method, we will get the predicted value of yi, which is nothing but beta naught cap plus beta 1 cap plus into xi cap. This will be the predicted value of yi. And from equations 1 and 2, we will get the actual values of yi cap, which is nothing but yi cap is equals to beta naught cap plus beta 1 cap into alpha naught cap plus alpha 1 cap zi. This will be the final value where covariance between zi and epsilon I is equals to 0, as we have stated in stage 1. So this completes our two-stage problem, two-stage method or two-stage technique, and here we will get our final outcome. So the predicted values of beta naught cap and beta 1 cap comes out to be y bar cap minus beta 1 cap x bar cap, and this will be summation I goes from 1 to n xi cap minus x bar cap into yi minus y bar cap upon summation I goes from 1 to n xi cap minus x bar cap whole square. This will be our final predicted values of the estimators. This completes your 2SLS method. I hope you understood all that we have done in class today. If you still have any doubts, you can, if you have doubts in the something of previous part, then you can revisit our previous video lectures. And if you have doubts in the current section, then you can ask in comments or WhatsApp number. And I hope you are doing all of this with us. start preparing yourself because the exam is coming nearby. Thank you.